This is topic 6.2, definite integral. And a definite integral means to find the area under the curve with respect to the x-axis from one x value to another. Okay, so it is definitely from 0 to 4. Now, we will be integrating with no limits of integration, and those will be formulas, not numbers. And so a definite integral has limits of integration. So let's go ahead and begin with this curve. We are given the graph of f of x, that's what it says. And let's first begin with the integral from 0 to 4 of f of x dx. So basically, that's this area under the curve. Now we're going to use geometry if we can, and that is half of a circle. And so the area from 0 to 4 would be 1/2 pi times the radius squared. And if you notice, this radius is 2. Pi r squared is the area of a circle, of course. So we need 1/2 pi r squared. And that will be 1/2 of 4, which is 2. And then we still have our pi. Okay? How about the integral from 4 to 8? Well, I'd like to kind of break that up. Let's go ahead and I'll use a different color pen. So I have a triangle there, and I have a triangle there. So the total area under the curve that I would like would be that triangle plus that rectangle plus the area of that triangle. And so you could also count units if you'd like, but sometimes it's nicer just to use the formulas. So let's go ahead and look at this triangle, the first triangle, and the area of a triangle is 1/2 base, which is 2, times height, which is 2. And that is equal to 2. And now you can see that that's a total of 2 units. And then let's go ahead and find the area of that rectangle, and it's 1 times 2 plus, and of course that's 2. And then we have the area of this small triangle, 1/2. My base is 1 and my height is 2. So as you can see, we have 2 plus 2 is 4, plus 1 is 5. You could have also counted those units. This area is 1. How about the integral from 8 to 12? Now, you have to be careful because the integral from 8 to 12 is below the x-axis. And anytime you have area that's below the x-axis, it is going to be negative. Yes, I said it, negative area. So let's go ahead and do that. And we have to be careful because the height of this triangle here is 2, or you could say -2. And then, of course, the base is 4. So let's see what we have. 1/2, base is 4, and height is 2. And that's a -4. And why don't I put the height as -2? Sometimes that's a good way to remember that. Just go ahead and use a negative for that height right there, -2. Okay? And then how about from 0 all the way to 12? Well, yes, you guessed it. The integral from 0 to 12, and this is really good for our notation, is the integral from 0 to 4 of f of x dx plus the integral from 4 to 8 of f of x dx plus the integral from 8 to 12 of f of x dx. We can add areas, so why not? And that's equal to 2 pi minus 4, 2 pi plus 5 minus 4. And that's equal to 2 pi plus 1. I'm going to highlight these answers just to go ahead and make them a little bit more clear. So that really gives us a good idea of what area under the curve looks like. And that we can use geometry if we need to. Okay, moving on. I've asked you to set up the integral for the following. And you might say, whoa, I don't have those areas shaded. So please pause the video and shade these areas that I have given you, shown here in the blue. Okay? I think I was trying to move that over, and that's that pen that's in the way. So move those over here. So after you've shaded these in, now you've come back, and I would like you to set up the integral that represents that shaded area. So let's go ahead and begin with this first one. This is the integral from -2 to 3 of 1/9 x cubed dx. You could also write f of x dx if you'd like. And that's what that area represents. And if you want, you can go ahead and put it in the calculator in Math 9 and see what that actual area is. You know what? I think I'm going to use Math 9 on each one of these, just so you can get an idea of what this area is. So if you put that under Math 9 in your calculator, and the area from -2 to 3 of 1/9 x cubed dx, you will get 1.806. Pretty interesting, isn't it? So why would that be 1.806 when you're looking right in here and you can see that that's much bigger than 1.8? Well, it's that positive area minus this area. So any area under the curve that is below the x-axis is negative area. So you probably guessed that this was going to be positive, didn't you? Because there's more positive area here than negative area. Let's guess what this second area is going to be. Yes, it's probably going to be negative. This next integral is probably going to be negative because there's more area under the curve. Let's see. We'll go ahead and write this. And you shaded these in already, but this is the integral from -1 all the way to 4 of 3/4 x squared minus 2x minus 1 dx. And if we go ahead and put that in our calculator, going from -1 is our lower limit of integration to 4, and we have 3/4 x squared minus 2x minus 1 dx, and this was -3.75. So, were we correct? We sure were. There was more area under the x-axis than there was above. So, that ended up to be a negative. That integral was a negative integral. Now, I'm going to throw this last one in there. This area is not with respect to the x-axis, is it? If it was, you'd be finding this area, right? The area under this curve from 0 to 2. But that's not what's shown. And this is just a little bit of a challenge problem. I just want you to see it. Imagine this being turned on its side. So imagine right here that this y-axis now looks like this, and we want the area from here to here. You could think of that, okay? So this is a dy, okay? So this is actually the integral, look here, from 1 to 5, and those are y values, dy. Now, we have to solve this for x, this equation up here. So this is actually x is equal to plus or minus the square root of y minus 1 if you solve that for x. Now, this is the positive root, so we will use the positive root of y minus 1, and because it's above that axis, okay? And so we have the square root of y minus 1, dy. Now, if you'd like to know that area, you can count those units as yourself. But guess what? You can still use Math 9 with a dy. Math 9 is just a computation. It is a rough estimate of the area. So you can still use x's in place of y's just to compute that area. And that's about 5.333. Okay? Again, we will be coming back to that when we find volumes of rotation. But for now, I just wanted you to see we need area with respect to an axis. And that is area with respect to the y-axis. With respect to the y-axis. Okay? Let's keep going. Sketch a graph of the definite integral. And then use the calculator to find that area. So that's what we're going to do. And we'll first go ahead and take a look at this first one. And you can put this in your calculator if you don't know what this curve looks like. And we'll be talking more about this. But basically, this is the quadratic function, up 4 units and then opening down. So we don't have to have a very perfect curve, but I can give you a few points. There's one here. Where it begins. And then, of course, we have one here when x is 1, y is 3, -1, y is also 3, and so forth. And, of course, we'll hit the x-axis at 2 and -2. So you can kind of get an idea about what this graph looks like. Something like this. Okay? Now, if we want the area from -2 to 1, we want this area. So we could go ahead and use Math 9, and if you do that, you will get that this is equal to 9. Okay? So use Math 9. On your calculator for integral after you sketch it, okay? Okay, let's go to the next one. We all know what the square root function looks like. See if I can get that same colored pen. So it begins here at 1 because 1 minus 1 is 0, so the y value will be 0 there. And then it just sort of goes up from there. When x is 2, this is 1, and so forth. So let's just go ahead and give it a nice little swoop. So where do we want the area? We want the area from 2 to 3, kind of a small area. And if you put that in your calculator, you will get 1.218 if you use Math 9. Okay, let's go ahead and take a look at this next one. This is actually 1/3 x minus 1. So it is a slope with a positive 1/3 slope that hits the x-axis at 3, because 3 over 3 minus 1 would be 0. So this hits the x-axis at 3 when x is 3, y is 0. And how about when x is 0, y is -1? Well, we're pretty good because that's all we need to write the equation of a line. So let's see. I'm going to go down. Maybe it's about like that. I think so. I don't know if I drew a very good line there, but that'll do. Okay, and we want the area from -2 all the way to 4. Now, what's your guess about this area? Do you think the integral, do you think this is going to be positive or negative? You guessed it. This integral is going to be equal to a negative number because there's more area under the curve. In fact, when you use Math 9 in your calculator, and we're going to learn how to integrate these by hand, but when you put in that in the calculator, you get it equal to -4. Okay, let's talk about the properties of definite integrals, okay? And let's just sort of fill these out. What do I mean by zero integral? basically what we're trying to say is that, let's see here, we are going to have when the integral is equal to 0. That means if I have an integral, let's write it over here. Let me write the formula first, and then I'll give you an example. How does that sound? So the 0 integral is the integral from a to a of f of x dx. And that's equal to 0. I haven't accumulated any area because I haven't gone anywhere. In other words, I've just stayed at a. So an example would be the integral from 2 to 2 of x squared dx is going to be equal to 0 because those limits of integration are the same. Okay? Let's go ahead and go over to negation. And this is super important. And it looks like this. The integral from 1 to 3 of, let me write the formula first, sorry. So the integral from a to b of f of x dx is equal to the opposite of the integral from b to a of f of x dx. So what did I do? I interchanged the limits of integration. You could say I flipped them, and all I have to do is put a negative in front of that. Let me give you an example. So an example would be the integral from 1 to 3 of x squared dx is equal to the opposite of the integral from 3 to 1 of x squared dx. And there's going to be times you need that limit of integration, lower limit integration equal to something in particular, okay? So that will come in handy. So if you have k as a constant and you want to integrate from a to b of k times f of x dx, you can actually take the k out of the integral, go ahead and integrate f of x dx from a to b, and then multiply it by k. An example might be the integral of 2x squared dx from, let's say 1 to 2, is equal to 2 times the integral from 1 to 2 of x squared dx. You know what I did? I forgot that 2 in there. What a mess. The integral. Let me just write this side over. You know, I think I have my eraser too big. So back here, let me start over. The integral from 1 to 2 of 2x squared dx. And then you can take the 2 on the outside of the integral. Okay? Now, you're going to really love this decomposition. It's really cool. So there's some number c between a and b. So the integral, oops, this is a property, so I need to put it in pink. The integral from a to b of f of x dx is equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. So basically what they're saying is you have this line, here's a, or not here, there's a number line, let's say a and b, and let's say c is here. So if you want the entire integral, or the area under the curve from a to b, you can just take the integral from a to c and add it to the integral from c to b. It's very, very handy. Okay, let's look at our addition rule, and you'll really like this. The integral of a sum is equal to the sum of the integrals. Kind of cool. So you can break up your sums very, very easily. An example might be the integral from 1 to 2 of 2x squared plus 3x dx is equal to the integral from 1 to 2 of 2x squared dx plus the integral from 1 to 2 of 3x dx. So you can break them up if you'd like. And subtraction is the same as addition. Okay? I'll go ahead and write this out. So it's the integral from a to b of f of x minus g of x dx is equal to, you guessed it, the integral from a to b of f of x dx minus the integral from a to b of g of x dx. So the integral of a difference is the difference of integrals. And I don't think we need an example there. Okay, so let's go ahead and work this last part. I think you'll really like these problems. We are given some integrals. Now, we don't know what f of x is. You can kind of see that here. We don't know what f of x is, but they go ahead and tell us that the integral from -2 to 1 is 4. The integral from 1 to 5 is -3. And the integral from -2, and those were for f of x. And then the integral from -2 to 1 of g of x is equal to 8. So let's see what we've got. We want the integral from 5 to 1 of f of x dx. Well, that's equal to the opposite of the integral from 1 to 5 of f of x dx. And that's equal to the opposite of -3, and we come up with +3. So it's kind of cool. Okay, how about the integral from -2 to 5? Now, what do you notice? And this is of f of x. We have -2 to 1, and we have 1 to 5. And so that's actually equal to the integral from -2 to 1 of f of x dx plus the integral from 1 to 5. Of f of x dx. And that takes us from -2 to 5. And that's actually equal to 4 plus a -3, and that's equal to 1. Okay, let's go ahead and take a look at C. We have the integral from -2 to 1 of f of x plus 2g of x. This is going to be cool. That gives us the integral from -2 to 1 of f of x dx plus 2 times the integral from -2 to 1 of g of x dx. So what did we do? We used the integral of a sum is the sum of two integrals. And then we also used this constant multiplied by a constant. Sometimes we call it a constant rule, where we took this 2 and we took it on the outside of the integral. So it makes it very easy. So let's wrap that up. That's actually equal to 4 plus 2 times 8. And that's equal to 20. Okay? How about the integral from 0 to 1 of f of x dx? Well, we don't have that information. There's no way to know. We don't even know what f of x is. So at this point, we can just say not enough information, or you can just put not possible. Not possible to evaluate. We can't just make up a function. Okay, how about the integral from 1 to -2 of 3f of x dx? You're going to like this one. That's the opposite of the integral from -2 to 1 of 3f of x dx. And now let's use our constant rule. That's -3 times the integral from -2 to 1 of f of x dx. And then we have -3 times, and we were given that -2 to 1 of f of x dx is equal to 4. So we have a -12. Okay? And last but not least, look at f. Do we even have to think for a moment? We shouldn't have to think, because look at those limits of integration. They're the same. Whenever you see that, that integral is equal